Welcome to Study Loop.
To test whether the average credit card balance of 18 to 20-year-old college students has decreased since 2016, we can set up a hypothesis test, where the null hypothesis is that the average credit card balance of 18 to 20-year-old college students has not decreased since 2016 and would be the mean of $569. The alternative hypothesis is that the average credit card balance of 18 to 20-year-old college students has decreased since 2016. So mu is less than 569. All right, so now that should help you with the first part. Determine the appropriate critical value. Well, we know that the sample mean is $549. We know that the sample standard deviation is $69.25. We know that the sample size was 40. We know that the population mean is $569. And the critical T would be, the degrees of freedom would be one less than the sample size. So our critical T, that is left-tailed with 39 degrees of freedom at a significance of 0.05, to 3 decimal places would be, negative 1.685. So go with choice A. And that again was negative 1.685. All right, so now we need to find our test statistic. And that's calculated as the sample mean minus the population over the sample standard deviation over the square root of the sample size. And so that's going to be 549 minus 569 over 69.25 over the square root of 40. And we're taking this to 2 places. That would be negative 1.83. And the conclusion then, since our test statistic is more extreme, it's more negative than our critical value, we would reject the null hypothesis. There is sufficient evidence to conclude that the average credit card balance of 18 to 20-year-old college students has decreased since 2016. Does changing the value from 0.05 to 0.01 change things? Well, if we looked at the p-value, let me do part C here. The p-value from a t-score of negative 1.83 with 39 degrees of freedom, and this being one-tailed, is a p-value of 0.037 to 3 places. So if we were to change this from 0.01, so not see how this is, you would reject at this level of 0.05, but if you change it to 0.01, then the conclusion should the conclusion will not be to reject the null hypothesis. It would be fail to reject the null hypothesis. And that would be because the test statistic is less than negative 1.685, our critical value. So fail to reject, this is B. I don't know what your options are exactly, but it's because the test statistic is less than our critical value of negative 1.685.